All right, Unit 11 deals with series and sequences. And you're going to learn later on in the unit basically the difference between the two. But when it comes to sequences, it's like 2, 4, 6, 8, 10, and so on. Numbers that have some pattern that they follow. A series is basically when you take those numbers and you add those up. So, and we'll take a look at some of those today and some of the notations. But before we go ahead and get started on this, let's go ahead and take a look at just a warm-up just to get used. You guys have probably seen these a lot back in elementary school, middle school. But number 1 says, name the next number in the sequence. So 2, 4, 6, 8, 10. So we're going up by 2 every time. So naturally, the next number would be 12. Okay? So item number 2 says, we want to write an equation that would give you the next term. And we don't want to use the previous term. So in other words, you could view this as, oh, wait a minute, I just took this plus 2, I took this plus 2, and I took this plus 2. So I don't want to use the previous term in order to get the next term. So here's what we're going to do. When you're looking at a series, this is our first term, this is our second term, this is our third term, this is our fourth term, our fifth term, and our sixth term. So whenever you're writing a rule, and we're going to talk a little bit more about this later on, but whenever you're writing a rule, you want to make sure that you actually, when you're writing the rule, you want to make sure that you look at these. So basically, how do I go from 1 to 2? Well, I'm taking that times 2. How do I go from 2 to 4? Well, I'm taking that times 2. How do I go from 3 to 6? I'm taking that times 2. So you quickly find out, so I'm taking 1 times 2 is going to give me 2. 2 times 2 is going to give me 2. 2 times 4, the next number would actually be 3, and I take that number times 2. Next number is the fourth number, and I'm taking that number times 2. And then I'm taking 5 times that number, and that's going to give me 10, and then I would take 6. And if I continued this pattern off, next number would be the 7th number, and I would take it times 2, which would give me 14. So you can quickly, they all have a 2 in common, and I'm just going to take that, whatever number it is, times n. So n will always represent what term in the sequence it is. So if I wanted the 100th term, then I could plug in 100 here and find out that the 100th term would be 200. Okay. Well, let's look at some vocabulary. We'll work a little bit more on writing the rules, because writing the rules is probably the hardest part in this unit. When we're looking at vocabulary, first of all, the terms are the set of numbers in the sequence. And we're usually going to denote those with an N, but they're the set of numbers in the sequence. Okay. The sequence is a function whose domain is the set of consecutive integers. So each term, so when we look back at our 2, 4, 6, 8, 2, 4, 6, 8, the 2 is a term, 4 is a term, 6 is a term, and 8 is a term. The sequence is this, or when you're looking at all 4 numbers, that's called the sequence of the numbers. Okay, the 2, 4, 6, and 8. That is the sequence. Okay. Feel free to pause the video as you need in order to get these vocabulary terms written down. A finite sequence is basically a set of numbers that stop. So if I said, what are the first 4 terms of this sequence, then you'd be done. An infinite sequence, basically it continues on forever and ever and ever. And we're going to denote an infinite sequence. If I wrote our 2, 4, 6, 8 again, usually it's got periods at the end. Okay. A series is basically whenever you take a sequence, and we're only going to be worried about finite sequences for this unit, but it's basically whenever you take a sequence and you find the sum. Okay, so that's what really all we're worried about is we're going to be finding the sum. So we're going to add all the numbers up. Okay, and the nice thing is there is some formulas for some of them that we can actually use. So that's nice. And then summation. The notation that we're actually going to use is a sigma, and it kind of looks like a little e. Okay, and we'll talk about later on what that means, because there's different components of that. Okay, all right. So let's go ahead and take a look at a couple of examples, and we want to write the first 6 terms of the sequence. Well, whenever I'm talking about a term, n is always going to be our term. So our first term is represented by 1, second term is 2, third term is 3, fourth term, fifth term, and then the sixth term. So each time you do this, all you're going to do is you're going to replace the n with one of these numbers. So n, 2 times 2, or 2 times 1, plus 3. Well, 2 times 1 is 2, plus 3 gives you 5. So there's our first term. Next one, we're going to replace the n with 2. So 2 times 2 plus 3. 2 times 2 is 4. 4 plus 3 gives me 7. And you may quickly find out the pattern, and you can finish these out. But let's go ahead and do it this way. So next one, I want to replace the n with 3. So 2 times 3 plus 3. So 2 times 3 gives me 6. 6 plus 3 gives me 9. 2 times 4 plus 3. So 2 times 4 is 8. 8 plus 3 gives me 11. 2 times 5 plus 3. So 2 times 5 is 10. Plus 3 more gives me 13. And the last one, 2 times 6 plus 3. Well, 2 times 6 is 12. 12 plus 3 gives me 15. Okay? So this is our sequence. And typically you're going to see those written with commas and just like a list. Okay? When we're looking at the next one, you're going to do the exact same thing. Okay? So the first 6 terms. So the first term is n, so it's going to be negative 2 to the 1 minus 1. Negative 2 to the 2 minus 1. Then it's going to be negative 2 to the 3 minus 1. Negative 2 to the 4 minus 1. Negative 2 to the 5 minus 1. And negative 2 to the 6 minus 1. And we're just going to evaluate those. So if we took a look at those, 1 minus 1 is 0. Well, negative 2 to the 0 gives me 1. Next one is negative 2. 2 minus 1 is 1, so negative 2 to the first power is just negative 2. Negative 2, 3 minus 1 is 2, so negative 2 squared gives me 4. 3 minus 1, or 4 minus 1 is 3. Negative 2 to the third is going to give me negative 8. And the next one, 5 minus 1 is 4, so negative 2 to the fourth is going to give me a positive 16. And the last one, 6 minus 1 is 5. Negative 2 to the fifth power gives me a negative 32. Okay? All right, well, we're writing a rule. Let's take a look at this example. Now, when you're writing a rule, the rule has to be able to apply to all of the problems. So, for example, we want to write the next term and then a rule for the nth term. So 2 times 6 plus 12, or 2, 6, 12, and 20. So we want to be able to write the next term. So remember, easiest way to do this is think about, okay, this is our first term. This is our second term. This is our third term. And then this is our fourth term. Okay? So we've got to do something to 1, 2, 3, and 4. Okay? Well, think about it. How can we go from 1 to 2? And there's a variety of ways. You could add 1 plus 1. Okay? Maybe I could just add 1 to it. If you add 1 to this, do you get 6? And you find out that that's not the case. Okay? Well, maybe our 1 represents n. Okay? Because remember, we're going to eventually put this in terms of n. So if I put this to plus 2 then, because n plus n, well, that doesn't give me 6. So we've got to figure out a way. Well, I could multiply this times 2, right? 2 times, but remember, I've got to do the same rule. So I got to multiply this times 6. So I got to multiply this times 3. So let's go ahead and stick with this pattern. How am I going to get 12 for my third term? Well, I can multiply this times 4. And for the fourth term, I can multiply that times 5. And remember, the 1 out here represents our n, and n is just the number of the term. Okay, so we're looking for that nth term. So what do we got to multiply an n times? Well, if you look, this is actually just 1 more than that. So we're going to do n plus 1. Okay, so when you're doing these, a lot of times it will help if you write down what term it is and how you're going to actually end up with that term. Okay, so that's what your rule would be, to find the nth term. So if you wanted to find the 50th term, then you could just plug it in and find out that it's going to be 50 times 51. And that would be our 50th term. All right, next one. Now, remember I told you about the sigma. So first of all, anytime you see a sigma notation, this means sum. You're going to find the sum of these problems, okay? So that's what this symbol means. It's known as the sigma notation, okay? It's a Greek letter. This right here tells us where we're going to start. Okay, we're going to start when I is 1. This tells us where we're going to stop. And this is our formula. Oh, why? I put an E on that stop. And this is our formula. So when we're doing this, all you're going to do is exactly what we did. Well, I is 1. Then it goes 2, 3, 4, 5. Okay? So we start at 1, and the top number tells us where we need to stop. So all we're going to do is plug this in. It's going to be 3 times 1. Next term is 3 times 2. Next term is 3 times 3. 3 times 4. And 3 times 5. And then the only thing is, once we find those numbers, we're going to add each of them up. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And 3 times 5 is 15. So all you have to remember is that sigma notation means find the sum. And you're gonna find the number in the sequence and then just add them up. Okay? This is actually called a series. And so we find out that our answer is 45. Okay? All right, so go ahead and pause the video. And we got 2 of these. The first one I want you to go ahead and try. So find the sum of the series. Remember, the bottom number tells us where we're going to start. Top number tells us where we stop. And then what's outside tells us what our actual formula is. So go ahead and pause the video, and let's see how you do. All right. So remember, our I is 2, so we're going to go 2, and you go just in order. We start at 2, then we go 3, 4, 5, and we're going to go to 6 this time. Okay? So I'm going to do a shortcut. I don't expect you to write out 2 times 2, 2 times 3. Just know we got to do this. So this one, 2 times 2 is 4, plus 2 times 3 is 6, plus 4, 2 times 4 is 8, plus 2 times 5 is 10, plus 2 times 6 is 12. And then we just add those up. 4 plus 6. Oops. 4 plus 6 plus 8 plus 10 plus 12. Gives us an answer of 40. Okay? All right, next one. Same thing. Go ahead and pause the video and see if you can do this one. All right, so let's go ahead. Remember, we're starting at 1. We're going to go to 2, 3, and we were going to stop at 4. Bottom number tells us where to start. Top number tells us where to stop. Okay? So our first one, this is our formula, so we're going to take our, and this should be a k. We're going to take our k squared, and we're going to square it. So 1 squared is 1. 1 plus 2 gives me, first term is 3. Plus, now we're going to do 2, so we're going to do 2 squared. 2 squared is 4. 4 plus 2 gives us 6. Plus, next one is 3. So we're going to 3 squared. 3 squared is 9. 9 plus 2 gives us 11. And the last one, 4 squared, which is 16. 16 plus 2 then gives us 18. And we just find the sum. 3 plus 6 plus 11 plus 18. Oops. 3 plus 6 plus 11 plus 18. And the answer is 38. Okay. Well, that concludes lesson 11.1. Just remember, as a quick recap, a sequence is a list of numbers. A series is when you basically add those numbers up. And right now they will be, whenever you see the sigma notation, this number here tells us where to start. This number tells us where to stop, and we use this formula to find those numbers. So find the numbers, then simply just add it up. Okay? All right. Good luck.